discuss. So, see, last class we have seen this thing that for the DC series motor and also for the separately extended DC motor. Okay, we uh, we uh, we just gone through this motoring mode, regenerative mode, and dynamic braking mode, and both regenerative and motoring mode. Okay, so this we have seen for both the separately extended motor and DC series motor. Okay, so now today's class we will see the closed loop control of the motors. Okay, first one is this one, current limit control. So what is this current limit control? So what it does actually? So we'll see here. We'll see the block diagram. What you find out here is that, see, if you look at the block diagram, so this is current limit control. So it limits the current. So why it limits the current in the sense? So if you don't limit the current, then there is every possibility that it may damage the circuit. Okay, it may damage the circuit. Okay, so it just go on increase like that, then it may damage the circuit. So to avoid this not to happen, you go for this current limit control. So what you find out in the block diagram is there is a motor is there is a load is there. So every motor, see here, this is the motor, so it requires supply, electric supply it requires. Okay, so you can consider that there is electric supply here. There is electric supply here. So and then what is there here? To this motor, load is connected. It is generally any load is mechanical load is connected to every motor. So now before the motor, what do you find out? A converter is there. So what is the purpose of this converter here? The purpose of this converter is that how much supply you have to give here. Okay, so converter. What is the purpose of a converter? You have seen the phase controlled converter. You have seen DC converter. You have seen. Okay, and some more kinds of converters. As see here, as you require here DC supply, as you require here DC supply. Okay, so it requires a DC supply here. It requires a DC supply here. It requires a DC supply. So this converter, because the motor requires DC supply, so this converter, okay, so will convert anything which is there into DC supply and it supplies to the motor. Now one more thing is that in the converter you have the firing angle is there. So when you change the firing angle, different voltages you will get. So when you get the different voltages, so as per that, the speed and torque of the motor also changes. So now that's the purpose of. So what is this converter? Before we go to the controller, we see this current sensor is there. So what is the purpose of this sensor? So it senses the current. So how it senses the current in the sense? Some sensors will be connected to the armature circuit. So from the current sensor of the armature circuit, okay, or field circuit. So this is IF is there. So field circuit is there. So wherever you want to sense the currents, whether it is armature or whether it is field, there you put the current sensor. So from there you extract. Then there is a threshold basic logic is there here. This one. So what is this is that there is Imax value will be there. There is a fixed value there Imax. So now the output of this block will be activated only when the current is more than Imax. See, the purpose of this entire block diagram is to limit the current. There is no other purpose of this block diagram. Okay, so it limits the current. So there is a block is there. It senses the current. So once it senses the current, then it will check whether it is more than the maximum value or less than the maximum value. So if it is less than the maximum value, then it just bypasses. It goes directly and it forms the closed path once again. So it flows like that. So it runs as it is. But when it is more than the maximum value, then this will activate and it limits the current to the maximum value. Whatever may be the value it is more than, then it limits the value so that it remains there. So what is the problem here is that if the field current is more and more, then there is a problem that the circuit may enter or the field circuit may enter into saturation. Okay, this is one of the problem you will face. Okay, so you require a current limit control. So the purpose of the current limit control is that it fixes the maximum value. So from the data sheet you can fix the maximum value. So that maximum value you will put here in this block. Okay, then this will limit. If it is less than the maximum value, it won't limit. It runs as it is. So controller, what is the controller here? You know, everyone you know this thing that whenever there is, so this is error detector. I can say error detector. This is error detector. So I hope you might have seen these blocks in even the control system also. So this error detector will find the error, then that error goes to the controller. Then as per the response, it gives the command to the converter. Then as per that, it decides the value of alpha. Okay, then based on the alpha, you will have some voltage. That voltage go to the motor. Then once again the current will. So this is a closed path completely. So this will continue. Okay, till for every time till it controls or till it limits the current. Okay. Next we will go to another block diagram. This is also closed loop block diagram. Okay. So what is this is that it is closed loop torque control. It is closed loop torque control. So now this one will control the torque. Okay, it controls so it controls the torque in the sense first you will set here. I hope you know this this one. This is error detector. We call it as error detector. So to this error detector, generally one side is positive, other side is negative, so that the difference between these two, okay, will come here as output. Okay, so the output of this picture or the output of this block is the difference of this signal and this signal. What is this signal? This is T star. This is the set value. Set value in the sense, I'm sure that you might so as now you are in third year, so you might have gone to this control system laboratory. In the control system laboratory, okay, some you might have seen some, okay, some experimental setup you might have seen. There you can set there you can set some values, you can set the firing angle, you can set or the current value, voltage value, you can set. Even the power electronics laboratory also you might have seen this setting you take. So you will set the torque value. So a particular value of torque you will set. Okay. Then once you set this, what is happening? Same thing here. You see this one common thing you will find out here: motor, load, converter. This setup you always find out in every closed loop block diagram. Why do you find out like that? Because every motor is connected to a load. That's the purpose of the motor. So it drives the mechanical load. Okay. And what is the purpose of the converter? The purpose of the converter is that to give the controlled DC. So here you get the controlled DC. So you will get the controlled DC here. So who will control this DC? So of course this converter will give the controlled DC. But who will control this star controller or speed controller or current controller? Any one controller we will find out here. So that controller will give the command to your converter. Of course, inside the controller you may have some other components also there. Okay, so like PWM controller. So at the end, the converter gets the firing angle. If it has thyristor, generally thyristors only we are using because you know because of this high power configuration, we generally use the thyristor controller only. So thyristor controller in the sense it requires firing angle. So this firing angle comes from this torque controller. The firing angle comes from the torque controller. Then this firing angle will go to the converter. So then converter knows that what is the firing angle. 20, 30, 40, 60, what is the firing angle it takes. So based on that firing angle, okay, based upon this firing angle, so it generates the control DC. So based upon that DC, whether it is more voltage is there, less voltage is there to the motor, then based upon that its speed and torque will be decided. Okay. So now closed loop torque control in the sense, see here you will sense the torque here. There will be torque sensors will be there. Okay. So the torque sensor will sense. Then based upon, so this is the actual torque. I can say actual torque. This we call it as actual torque. Actual torque in the sense, now what is the torque developed by the motor that it will sense. So that signal will go here to this one error detector. So then already you have set some torque. Then what is the actual torque? So this is set torque, whereas this is actual torque. So it is set torque, and this T is actual torque. Actual torque. So both will be compared. So if there is any error, if both are not same, then there is error will be there. Some error will be there. So that error goes to the torque controller. Then the torque controller will decide for this error how much alpha should be there. If the error is very less or if the error is zero, then this torque controller will not give any kind of extra command. Rather, it will give the previous alpha itself. So the previous alpha will be maintained. But if there is error, then the torque controller will change the value of alpha. That goes to the converter. Then if alpha changes, then the output of the converter also changes. So the voltage to your motor changes. If the voltage to the motor changes, then speed torque may change. So then torque changes here. Then once again you sense here. Then actual torque. So once again it will compare to the set torque. If there is no error, then it is zero. Then that's it. So likewise, it tries to control the in closed path. It tries to control. It's a closed path. So previous one is also closed path only. So every time it senses and it will compare with the set value. Every time it senses, it compares with the set value. Based on the error, it will actually torque control in the sense the block diagram. This is the torque control block diagram. It controls the torque. It means why they are giving this name torque control is that the main function of this torque control is that to control the torque, and based upon that it generates the value of alpha. A few things you must understand here. So till now we have seen two block diagrams. In both the block diagrams, few things are common. What are the common things I will write here so that you will get used to that. One is motor, another is converter, another is load, another is controller, another is sensor. Yes, then another is error detector. You see, every block diagram you will find out all this. So these three are very common. Okay, that is converter, which supplies the motor. Load, which load is the one to the motor. So there is always load is there, fan is there, or washing machine is there, or mixer is there, grinder is there. So that is the load. That is the load connected to your motor. Converter in the sense now the motor requires supply, so the converter will give supply to the motor. Now that converter is not uncontrolled one. Remember, it is a controlled converter. It's very important. It must be a controlled converter. The controlled converter in the sense the converter which has control switches, thyristors, IGBTs, BJTs, these kind of switches you will find out. Okay. So now controller. Now what is the function of the controller? Whether it is speed controller, whether it is current controller, whether it is torque controller or a voltage controller. Commonly it is a controller. So what is the purpose of this controller? The purpose of the controller is that it generates a control signal. Okay. So now not it generates a control signal. So its output goes to the converter. The controller outputs go to the controller. So it will decide the value of firing angle, or it will decide the control signal. It will decide the control signal. So how it decides what is the input to this? That's the question. What is the input to this? The input to this is that error from the error detector. The input to the controller is nothing but the output of the error detector. Based on the amount of error, it will generate the value of alpha. Okay. Then what is the last one now left? Sensor. So what is sensor? Sensor. Without sensor, you will never know what is the actual value. Without sensor, you will never know what is the actual. Whether see, maybe voltage sensor is there, current sensor is there, speed sensor is there, torque sensor is there. So sensor, it will sense a signal. So I hope you know how the sensor works. So how the sensor, see, and one more thing you must understand here. See, this entire block diagram, so the signal flow is there here. See, from motor to sensor, then there is a signal here. So this signal flow is there. Okay, this signal flow is there. I will tell you one thing that from motor to torque sensor, the signal is a what is signal is a it's a mechanical signal. It's a mechanical signal. Mechanical signal is there. Then this torque sensor will convert mechanical signals into electrical signals. So what is the purpose of the sensor? What it does, sensor it converts any physical signal to electrical signal. So it converts electrical signals in the sense what? Either voltage or current. These are electrical signals. So the torque sensor, say for example, it generates the voltage. It generates some voltage. Torque sensor generates some voltage. That voltage is proportional to the torque of the motor. That voltage will be proportional to the torque of the voltage. So torque of the motor, that voltage. So it generates a voltage which is proportional to the torque. More torque is there, more voltage it generates. So this voltage will go to this place here. So once this voltage go to this place, then you have another set torque is there. So remember now, set torque is also, it's not a torque. This set torque is already converted into voltage signal once again. Voltage signal. So this voltage signal, okay, and the voltage signal here, both will be compared, and the difference voltage will come here. So the flow here, see the signal flow here, the major signal flow here till this motor, from the torque sensor to till this motor, this flow of signal is electrical signal, not mechanical signal, you must understand. So this is a okay, so electrical signal, either it is voltage signal or it is current values. Some voltage will be there or some current value will be there, okay. But only the sensor will convert the physical signal to the electrical signal. So this is about the closed loop torque control. Then we go to another one. Closed loops. Now you see here. Some more things are there here. Some more common things are there here. You must understand. So first of all, it is a speed control. So whenever you are controlling speed, definitely you must understand there should be a speed sensor, because whichever signal you are, till now you have seen current control and torque control. So both in current control and torque control, what you have observed? You have observed one important thing. What is that you have observed? You have observed that if in current controller there is a current sensor is there. In torque controller there is a torque sensor is there. Similarly, in the speed controller, you will have a speed sensor. So how do you sense the speed here? How do you sense the speed here? So now remember, I told you already the purpose of the sensor is to convert the purpose of the, so here you have a physical signal in the sense, in this case, speed. Here you have electrical signal. So previous case you have torque sensor. So the physical signal is torque there. Now the physical signal here is speed. So it will sense the speed. I hope you might have measured the speed in the machine's laboratory also using the tachometer. I hope you remember this tachometer. So using the tachometer. So what this tachometer does actually inside, when you insert that small knob into the uh, armature of the motor, okay, armature of the motor. So generally here, see here the load speed we are controlling here, not the motor speed. But there is no much difference between the motor speed and the load speed. There is no, except some losses will be there, some rotation losses is there. Okay, except the rotation losses, the motor speed and the load speed will be same. Okay, so here we'll sense the speed of the load here. It's better always you sense the speed of the load, because at the end we'll see the speed of the load. For example, fan is there, then we will not worry what is the speed of the motor inside the fan. We will worry that what is the speed the wings are flowing. So the load speed will sense. So just like it's a speed controller, and it's a closed loop. So I hope you remember the difference between the closed loop and open loop. So closed loop in the sense, continuously it will monitor, it will sense, and it will take an action, so that it will fix the speed to the set value. Like you have the fan there. So fan has some these settings will be there, 1 2 3 regulator settings will be there. So you set the speed here, just like okay, when you set the speed, what do you find out? When you set the speed based on, of course, the fan which you are setting there, I want to tell you one important thing, it's not a closed loop, it's an open loop. Okay, the fan at your home, it's not a closed loop, it's an open loop. Because you are not sensing any, you don't have any, you did not fix any sensor to your fan. Remember this thing. You are not because so you don't know what is the actual speed. You only just feel this thing that you will set using the regulator. Regulator has some positions, 1 2 3 4 5 like this. Then you set to some position. Sometimes you want maximum, then you set to maximum position. Then you will see yourself, okay, now the fan is running at maximum speed, so you will satisfy with that. So you don't require much, and you don't require that much accuracy there. So you will adjust to that. So you will adjust to that. So that's a open loop condition. So now it's a closed loop speed controller. So what you do is, now every time you sense the speed, then you compare with the set value. Now you see here the load is there. So this load speed will be sensed by the speed sensor. Then this speed sensor output goes to the error detector. So there I told you already, everything is electrical signal, not the speed signal. So this speed will be converted into some electrical signal, maybe some certain voltage, 1 volt, 1.1 volt, 1.2 volt, something volt will be there. So that volt go to the error detector. Then already you have set the speed here. Just like your regulator, you put the speed for the fan. Okay, so you set the speed here. Then some error will come here. This error goes to the speed controller. I told you already that controller is very common, and we give the name to that, whether it is a speed controller, torque controller, current controller, voltage controller. So the controller function remains same. Based on the error, it takes an action, and that action will go to here. So where this action is going now? This action is going to a current limiter. So this action is going to a current limiter. So what is the purpose of this current limiter? Now you have seen. I will redraw the picture here. What is there inside the block? So now, please see here now. So it's a current limiter. How I'm saying it's a current limiter? You see at this point or at this point, this part and this part, it's a horizontal line. It's a horizontal line. So horizontal line in the sense what? Constant. So if the current is here, then it won't do anything. It won't do anything. If the current is between point A and point B, if it is between point A and point B, it won't do anything. It just passes the signal. But if it is beyond point A or if it is beyond point B, then it will limit there. So it is a horizontal line. It means it will stop there. It will maintain this value. Here also it will maintain this value. That we call it as current limiter. So that current limiter, okay, will decide the value of current here. That's called current reference. So the current reference here is generated from the output of your speed controller. So based upon the speed controller, it goes to the current. So there must be a relationship between the speed and the current. Okay. So like you have this, I will write the relationship here. EA, E naught, I will say EB minus IA RA. Some relationship is there. There is a current is there. There is EB. EB, it has some speed is also there. Okay, so there is a relationship between, it's a function of speed where it's a current. So there is a relationship between speed and current. So based upon that relationship, you generate this current from the speed signal. That's it. There is nothing much to worry here. Only equations are sufficient, or equations are required here. So then that current is decided as the reference current. That current is this. So reference current is generated from the error. Depends on the error, reference current will be generated. That's very important. So once you have the reference current, then what is the actual current? This is the actual current. Actual current. So from where you are getting the actual current? You are getting the actual current from the current sensor. So from where current sensor? So current sensor is connected to your motor. So motor current sensor is there. So motor has some current. So that current will be sensed by the current sensor. Then the output of the current sensors will go here. Then the reference current already you have generated from the speed controller. From the speed controller block, you have generated the reference current based upon the current limiter. Okay, so that reference current and the actual current both will be compared. Then what is the error? That error goes to the current controller. That's important. So once again there is a current. So you have here two controllers are there: speed controller and current controller. So based upon the speed controller, you will generate the current reference. Then based on the current reference, you will limit the current. So this current limiter is required. Otherwise, it will go beyond a certain value. So it may damage the system. So you require a current limiter. So based on the current limiter output, you decide the reference value and the actual current. So whenever you want to know the actual value, whether it is current or voltage or speed or torque or force, any kind of signal you want to know the actual value, you require a sensor. So the sensor will sense the current. So current sensors, even you might have seen, even current transformers are there. CT, you call it as CT. Current transformer, you call it as CT. So I'm sure that you might have seen this CT also. You will see the CT at the substations. In the substations where there is a metering is there, meter will be there in the substation. It means how much energy consumption is someone will be measured. Some meters will be there. So there in the substations of the metering, before the metering you will find out the CT. I'm sure about that. So this is CT, current transformer, can be used as a current sensor. But this is only when for high power loads only. For small power loads, you have a current sensor. Okay, some kind of current sensors. I would like to show you now here the current sensor. Okay, so means in power electronic circuits, okay, you will use some kind of current sensors. I will show you the picture here. Yeah, see this now. This one. Yeah, yeah. Please see this now. Yeah, now you see, this is one of the current sensors. Okay, so now there is a hole is there here. There is a hole is there here. You see now. Okay, so now this hole. Okay, through this hole you put the wire. Simple. Through this hole you put the wire. So the wire will go through this hole. So when the wire goes through this hole, then this black color shape will sense how much current is flowing through that. Then there are some terminals you will find out somewhere. You see here, here. Yeah, you see the terminal here. One terminal is there. So likewise, the terminals it is. So I will show you in this picture. I think maybe you can find. Yeah, please see this one. There are terminals are there. Please see this. This is terminal is there. This also terminal is there. So now from these terminals, you can get the value, how much value is there. So across these two terminals, you can get the value. So you put the wire inside this hole. You put the wire inside this hole. Okay. Then so this is one of the several pictures you search in the net, you will get that. Okay. So you have the current sensor. Then after the current sensor, now the signal goes here. Then you have current controller and same. So based upon the error, the controller will give the value of alpha to the converter. Then the converter will give the required voltage based on the value of alpha. Based on the value of alpha, it gives the voltage based upon the value of the v. So its speed will change. Its speed and torque will change. So likewise you regulate. So once again you will sense what is the speed. Then if it is there is no error, then there is no action. So that's it. So this way the closed loop speed control is there. So you must understand the closed loop speed control. You have a speed control and also you have a current control. Yeah. You have only one thing is left now. So current limit controller, torque controller, speed controller. Now last one there is another one is there. Last one. Yeah. It is the total block diagram of closed loop controller of DC excited motors. This is the entire block diagram. So this block diagram you see many of the controllers you will see in this block diagram. Okay. In these block diagrams, you will see many of the controllers. So
Sir, your mic is off, sir.
Yeah, please tell. Till now, not sorry. Okay, I think I have purposefully I have turned off the mic because of some disturbance. Okay, now you tell me that before that did this three block diagrams you got the noise means you got the sound that is was it audible?
Yes, sir, your
That,
voice was audible, sir.
okay, now this one,
Audible, sir.
this fourth one is I have to start over. I will start over once again. Please, thank you for reminding this. Okay. Okay, now you see now this is closed loop controller for DC excited motor. Now this controller, this entire block diagram, so many blocks are there. So all these block diagrams, okay, all these blocks, okay, so they are common for almost every DC excited motor. Now, of course, in here we are studying only two separately excited DC motor and the DC series motor only we are studying as of now. Okay, so now in this, what you must understand here is that please see here. Controlling the motor is nothing but you see yourself as of now. What is the controlling the motor? The motor output terminals will control. What output variables will control? Will control. So what are the motor output variables? Speed or torque. These are the output variables of the motor. So many times we control the speed or we control the torque of the motor every time or many times. So mostly we control the speed because in many applications you will see, in many of the applications we will see what is the speed. We always you go to any factory, okay, you go to any manufacturing unit, okay, there you every time you should be very careful in the accuracy of the speed. So controlling the motor is nothing but controlling the speed. That's the general thing. So we'll start from here that this is the motor, and we'll start from the motor output. What is the motor output here? That is the speed is there. So the speed is there. So this picture, this small circle I put here, this is a speed sensor. Speed sensor. So it senses the speed of the motor. Okay, so once it senses the speed of the motor, then this electrical signal, that is a speed signal, I will say speed signal. Of course, it is in the form of electrical signal only. It is in the form, not in the mechanical signal, electrical signal. So this electrical signal, that is the voltage or current, whichever may be. So where it is going now, please see here, where it is going now through this line which I have drawn here, it is going like this, it is going like this. Then it goes to this error detector here. So you call this as actual speed of the motor. That actual speed of the motor you have sensed through the speed sensor. Then it goes to the error detector. Then there you have the speed. Set speed is once again the same thing that you have the fan is there. So you set the speed of the fan from the fan regulator. You set it 4, you set it 3, or you set it 5. So that you set here. So now the set speed and the actual speed. Now let me tell you, both are electric signals. So both the signals will be compared using this error detector. Then you will generate error here. So whenever there is error, then I told you already that as is you are sensing the speeds, as you are sensing the speed and the error is also speed, the controller which is after the error detector, you call it as a speed controller. The controller is very common. The naming is different. Okay. So the speed is here you are comparing the speed. So the speed control. Then after the speed control, what do you find out? Current limiter. You have the current limiter. Just like you have seen the previous one, the previous block diagram you have seen. What is the previous block diagram? You are sensing the speed and there is a speed controller. Then after speed controller, it goes to the current limiter. So it limits the current. Once again, what is the picture? I show here. This is the picture. The picture. So you see the picture here once again. This is the point A. This is the point O. So till OA, from O to A, okay, the limiter will not limit anything. It will sense. It will send the actual current. But after A, if it is beyond A, then there is a horizontal line is there. So it will fix the current there. It will limit the current there at this value, at this horizontal value. So that's the purpose of this current limiter. Once again, the same question that how do you relate speed and current? How do you relate the speed and current? So this equation is there. Which equation? That E naught is equal to EB plus IARA. So this EP is proportional to speed. So the speed is there, current is there. So based upon this relationship, you will design these blocks. So then it generates the current reference, armature current reference here. So you see IA. So this IA speed. So based upon the speed error, speed controller will give some signal that goes to, that passes through the current limiter. Then current limiter will limit the current value, and based upon the output of the current limiter, you generate the current reference. So IA star is the current reference. Remember, in the error detectors, wherever you find out the stars, that's the reference values. Okay, sometimes you set or sometimes you generate that. So that current reference, it will be compared with the actual current. So IA is the actual current. IA is the actual current. So now from where this actual current is coming? This actual current is coming from this line. Where this line is going. So now you see there is a symbol is there, I have shown. Obviously, it's important. I will redraw the symbol here. This is the symbol. Okay. Now this symbol, I will tell you, is for current sensing. Even you can search in the books also, you'll find out this symbol as current sensing. So you sense the current from this line. One line is there. Just now I have shown you a picture of your current sensor. I have shown you one picture of current sensor to you. Okay, so there you find out a hole is there. So that hole is this black color. So through that hole the wire goes. Through that hole the wire goes. Then the output of that sensor will be sensed here through this line. So the current is, so now the question is that which line is this? First of all, you must understand which line you are sensing. So this line you are sensing. Okay, this is the line you are sensing. Now where this line is going, actually, you see this line is going to the armature of the motor. See this now. So one line is going to the armature of the motor. So that line we are tapping. That line we are tapping. So from that tapping, you are sensing the current. So it means exactly we can say this thing as this line is going to the armature of the motor. The current which you tap is nothing but the armature current. So the armature current is here. So this armature current goes here. That's the actual current. So it will go to the error detector here. There it will compare with the actual current. So reference current, actual current, both will compare. Then you will get the current error here. So whenever there is a current error, you will have the current controller. That's it. So you don't need to think much about this. So current controller. Then current controller. After current controller, you have the firing circuit. See, this firing circuit block we did not draw in the previous block diagram. Actually, we just included this firing circuit block in the controller block itself. Okay. Now this block diagram, it has some more clarity. So after current controller, the output of the current controller will go to the firing circuit. Now you recall the firing circuit. Several firing circuits are there. For example, thyristors are there. Then thyristors has a particular firing circuits are there. BJTs are there. Particular firing circuits are there. IGBTs are there. MOSFETs are there. So every switches has some kind of firing circuits are there. What is the purpose of this firing circuit? I told you already in previous classes that one thing is that it will generate the accurate value of alpha. Another thing is that it will boost up the signal of the base signal. For example, if it is BJT, then you have to give base signal. So that base signal may be having very low power level. Then it will have to enhance the power level. Why it will have to enhance the power level? I think I told you. You might have known this thing from power electronics. That why do you need to enhance the base signal, or why do you need to enhance the control signal? The purpose of enhancing the current signal is that to make the switching fast. To make the switching fast, you generally enhance. Otherwise you don't require any firing circuit. Let me tell you one thing. The main purpose of the firing circuit is that one, to generate the accurate value of alpha. The other main purpose is that to enhance the signal which is going here. Now the base signal which is going here, the base signal which is going here. So the base signal, okay. So that base signal, switching sequence or the switching process will be rapid. That's the purpose of firing circuit. So the firing circuit block we did not include in the previous three block diagrams. Now we are including here. So, but there is a firing circuit block is always there. So the purpose of firing circuit block is that based upon the output of the controller, it will generate the value of alpha, and also it enhances the signal to make the switching fast. Then after firing circuit, where it is going? Now it is going to a block. Inside the block, what do you find out? Inside the block, you find out a so it's a phase control converter, or you can say it's a thyristor controller, or I will say, yeah, thyristor converter. You can give the name here directly. We have this topic is there even in power electronics controller. Phase control converter. What is it? Phase control converter. Phase control converter in the sense the converter having thyristors, and the converter which converts AC to DC using the value of alpha. So now you see the input to your one side, you find out AC supply. To whom? To the block of the thyristors. It means the phase control converter. I told you already, phase control converter will convert AC to DC. So it needs AC, so that AC is there here, and also it needs alpha. So okay, AC source is coming, and the firing angle is coming from the firing circuit alpha. So alpha AC source. So both combined you require to for the phase control converter to generate generating plus minus DC. Okay. So now this DC where it is going, this is the converter. See previous block diagrams I have shown you converter. I show you converter. So that converter is this picture now. So just some modifications of the pictures here. There nothing is there. To give more clarity here, we just added here as a condition. So it's a converter. So from the converter, the voltage where it goes directly to the armature. You see the line. This is the line. So this output of the converter goes directly to your motor. That's it. So it goes to the motor. Then after, so through this line, you are sending a current here that already have explained. Then there is a voltage sensing is also there. Please see here. There is a voltage sensing here. So you are tapping here. So you have a voltage sensor here. So through that voltage sensor, it goes here. This signal is VA armature voltage. So where this signal is going here now? Once again, this signal is going to another error detector. So that one side is plus, VA side is voltage of the output of the converter or input to the armature. So that goes here. Then this voltage VA will be compared with another signal. What is that signal here? See here, IA is there, already have sensed IA. So that IA, it takes another path. So two paths it has. One path goes to the error detector, another path is passing through RA. When a signal is passing through RA from the control system block diagram algebra, I am sure you know this thing that if this signal is IA, if it is passing through IA, then the output of this block is IARA. So that I have shown. So IARA is the output of this block. That IARA you are comparing with VA. So output voltage, input voltage, so armature voltage you are comparing with IARA. Then what is the signal here? We get VA minus IARA. Please see this yourself. VA minus, what is VA minus IARA? VA minus IARA is nothing but back EMF EB. If you recall, VA minus IARA in the motor is nothing but, so how you got VA? VA you got by tapping the point here. How you got IARA? You tap IA here, then that IA you pass through RA, then you will get IARA, then VA minus IARA you will get here. So then what is VA minus IARA? That's nothing but the back EMF. So you got the back EMF signal here. That's what you want to understand. So this back EMF signal goes to the value here. So now this back EMF signal will be compared with the reference. Then now let me tell you one more thing. See, back EMF has a relationship with your field flux. How it is so? Please I will show you that. EB is equal phi Z n by 60 into T by A. Now you see EB and phi has a relationship. So that relationship, okay, based upon that relationship, based upon the error here, okay, based upon the error here, the actual back EMF and the reference EMF. So based upon that, you have a value of some error. That error go to the field controller because you are controlling the field here now. Please remember, you are controlling the field here. So that field controller output goes to another firing circuit. Then that firing circuit will generate another alpha. Same procedure. Then you have the phase controlled converter once again. Phase controlled converter, PCC, phase controlled converter. So phase controlled converter you have another. Then that phase controlled converter will give another DC. So where that DC is going to the field winding. See here, we have got another block diagram here for the field winding of the motor. Okay, so the field winding is there. So this IF is there, field current is there. So this field winding is there. So you are controlling the field and also you are controlling the armature in this entire block diagram. So how you are controlling the field winding once again? So you give the different volt, a different DC to your field winding. How you give the different DC? Once again you need a converter. What is that converter? It's a phase controlled converter. So it requires AC supply, it requires alpha. AC supply you are getting separately. Alpha how you are getting? You are getting alpha from the firing circuit. So what is the input to the firing circuit? The input to the firing circuit is field controller. What is the input to that error? Error for back EMF error. So it means, so you are once again controlling the field also. So combinedly you are controlling field and also armature. So you want to control field, you can go through this path. You want to control the armature, you can go to this path. So this is the entire block diagram for the any DC motor. So the any DC motor you have armature, any DC motor you have field. So both the block diagrams are shown now. Armature, this is the armature flow, this is the field flow. So both you have seen. So commonly what you have seen, firing circuits you have seen commonly, converters you have seen, controllers you have seen. Okay. So based upon that, this entire process will be controlled. So the speed at the end will be controlled. Okay, so speed, how do you control you? I just want to know, I just want to tell you that you recall yourself. Why do you have field side? Why do you have armature side? Is that If you don't forget, I will just recall this thing in 1 minute. What is that? Is that if you recall the speed control of DC motor, you have two types of controller: armature control, field control. Please recall that. When do you go for armature control? When do you go for field control? There is above this base speed is there. I will write here. I will just remind. I will just recalling that above base speed, below base speed. So whenever you want to control the speed of the motor above base speed, you go for field control. Please recall that. If it is below base speed, you go for armature control. That's it. So it means the black diagram we have shown here, it has both armature and field control. You have here the process is simple that why you have both control systems. Whenever you want to go for above base speed, you go for field side. Whenever you want to go for below base speed, you go for the armature side. That's the thing. That's the process.